So we will be talking about how to graph these absolute value equations. And the thing about them that you need to know first is that the basic one, just y equals the absolute value of x with no extra numbers, is going to look like this V-shaped graph. And the most important thing about this V-shaped graph is that it has, I didn't graph it very well, but it should have the point 0, comma 0, and we call that point the vertex. Mine's a little bit offset because I don't have my fancy pen that lets me write well on this thing. But the idea of this graph, why it looks the way it does, is basically if you think about absolute value, if x is a positive number like 1 or 2 or 3, the absolute value of 1 is 1, so if x is 1, y is 1. The absolute value of, say, 3 is 3, so if x is 3, y is 3. So every x and y, you have the point like 1, 1, the point 2, 2, the point 3, 3. But if you plug in a negative x, what happens is the y value then becomes positive. So you have also points like negative 1, 1, or negative 2, 2, or negative 3, 3. And you get this V-shaped graph. And this vertex is how we're going to kind of pin these things down. We're going to use that and then just some tables to get things figured out. And the question we really want to ask ourselves is, what value of x would correspond to where this vertex ends up? Because, you know, if you've done the last few sections, you know this is just shifted and stretched around. So where did the vertex shift? Well, we want to figure out which x value would make this inside thing 0, because that's what the vertex of the normal graph is, 0. And with a little bit of thinking, you're like, well, if x is negative 1, this inside will be 0. So the next step then is to kind of build a table, and then let x equal negative 1. And then the second thing you may have noticed is that this graph has what we call symmetry. It's the same on the right as it is on the left. And so because of that, we want this to be a middle point, and we just want to pick a couple x values that are a little bit less than negative 1, or a little bit more than negative 1. Once we have that table of points, we'll just plug it in, and we'll see what happens. So a number next, the first number that I can think of that's less than negative 1 is negative 2. And then before that we have negative 3. And then after we have 0 and we have 1. And we're just going to take each one of these x values, plug them in, plot the points, see what happens. I'm going to pause the video. You can too while I do that last. This video is getting really choppy, I apologize. But basically, after doing all these different calculations, I'm going to find these different y values. And in case you're not getting these numbers, but you're doing the right thing, I'll kind of walk you through this one real quick. If I plug in a negative 3 plus 1 is going to give me negative 2. Then I'll take the absolute value of negative 2 as positive 2. Then positive 2 times negative 2 is negative 4, minus 3 is negative 7, you know. So it's the same way we're going to get negative 5, negative 3, negative 5, negative 7. If you pick the right x value here and you pick like these numbers to be the same distance away, like negative 2 and 0 are both the same distance from negative 1. They're both one away from negative 1. Negative 3 and positive 1 are both the same distance from negative 1. They're both 2 from negative 1. You'll see symmetry in the table. Like these values will match. These values will match. And then we're just going to plot those points. And I can't do it very well with this with my current tool set, but you plot, so I'll do my best. Negative 1, negative 3, negative 7 will be down here-ish. Negative 2, negative 5 would be here. Negative 1, negative 3. 0, negative 5. 1, negative 7. And then it would be a V-shaped graph like that. So good luck with that. It's really, like I said from the beginning, all about figuring out which x value is going to make this part 0 so that we can match that vertex. And lo and behold, that point is exactly where the vertex ended up. Not where I graphed it, but where it ended up. So good luck with that.